Hello students. Now we are going to discuss about one important reaction of alkenes, and that reaction is referred as formation of alkyl halides by the process of hydrohalogenation. Acha. Now as the name suggests, hydrohalogenation matlab you are going to add hydrogen as well as halogen to an alkene molecule. एक बार देखते हैं. Let's have a look at a basic form of the reaction. What exactly is the reaction all about? And then we'll go into its mechanistic detail. So firstly, what is hydrohalogenation? It's addition of hydrogen and halogen to the alkene molecule, and this reaction is therefore referred as hydrohalogenation of alkenes. Okay. Further, if you talk about the main aspect of the reaction, let's have a look at the main aspect. आप क्या करोगे? You will take a hydrogen halide like HCl, HBr or HI. They would add up to alkenes to give you the corresponding alkyl halides. मतलब HCl लिया तो chloride मिलेगा, bromine, HBr लिया तो bromide, HI लिया तो iodide. Again, HF is not preferred to be added over here. You won't add HF in this compound or in this reactions. Further, what we can say, let's have a look at the example. Further, what we can say that this reaction is an example of an electrophilic addition reaction like halogenation. अच्छा एक example देखते जल्दी से, and then we'll proceed further with the next part of the reaction. Let's see. Let's suppose you have a molecule of ethene, that is CH2 double bond CH2. अच्छा इसमें आपने क्या ऐड किया? Let's say you have added HBr. होगा क्या? A very simple addition will take place across the double bond. मतलब double bond जिन दो कार्बन्स के ऊपर है, बस उन्हीं दो कार्बन्स के ऊपर एडिशन होगा. तो एक कार्बन के ऊपर H ऐड हो जाएगा, एक कार्बन के ऊपर Br ऐड हो जाएगा. That's it. So what has happened? From a molecule of ethene, आपने एक molecule बना दिया ethyl bromide. Nothing more than that. Okay. Further, let's take one more molecule of propane. One more molecule of propene. So आपके पास propene molecule है CH3CH double bond CH2. Again you are adding HBr. लेकिन अब यहाँ पे problem क्या है? Let's see. Br might add to the first carbon atom. Then you would get a compound something like this: CH3, CH2, CH2, Br, which is nothing but one bromopropane. लेकिन there can be a situation where bromine might be added to the second carbon atom, giving you what? Giving you CH3, CHBr, CH3, and this compound would be referred as 2-bromopropane. Now over here, a question ये आता है कि out of the following, which one is a major product, which one is a minor product? So how would you understand which one is major and which one is minor? The answer to this would be given by a question, which is, or by a rule, which is called as a Markovnikov's rule. अच्छा, Markovnikov rule क्या बोलता है? Let's try to understand that also. It says whenever you have an alkene, it might be an unsymmetrical alkene or it might be a symmetrical alkene. Now, what do you understand by symmetrical and unsymmetrical? देखो, अगर मेरे पास ये alkene है जो ethene molecule है, and if you say ethene molecule के double bond को अगर आपने break कर लिया, तो इस तरफ भी एक कार्बन ग्रुप CH2, दूसरी तरफ भी एक कार्बन ग्रुप CH2, मतलब दोनों तरफ you have the same alkyl groups. Therefore, this alkene will be referred as a symmetrical alkene. Whereas अगर आपने प्रोपीन को ब्रेक कर लिया, तो इस तरफ आपके पास दो कार्बन ग्रुप CH, CH3, and on the right hand side you have only one carbon group which is CH2. So definitely this alkene is an unsymmetrical alkene, whereas ethene is a symmetrical alkene. तो पहली चीज तो ये समझनी है, symmetrical क्या होता है, unsymmetrical क्या होता है. Okay, now what does the Markovnikov rule says? It says that whenever you have an unsymmetrical alkene which is treated with an unsymmetrical reagent, then the negative part of the reagent goes to that carbon atom which contains less number of hydrogens. Meaning, एक बार वापस statement read करते हैं and then we'll process with the meaning. What does the rule says? It says that whenever an unsymmetrical alkene is treated with an unsymmetrical reagent, then the negative part of the reagent goes to that carbon atom which contains less number of hydrogen atoms. Meaning देखो, firstly HBr जो आपके पास है, can I say it can be broken down to give you H plus and Br minus. Okay, इसको तुम तोड़ सकते हो as H positive and Br negative. तो मुझे सबसे पहले ये बताओ कि इसमें से नेगेटिव पार्ट कौन सा है? नेगेटिव पार्ट इज Br minus. Now what can happen? So Br minus, which is the negative part, can either go to first carbon or it can go to the second carbon. If it goes to the first carbon, that means the carbon which was initially containing two hydrogen atoms, correct? Or if it goes to the second carbon, matlab to the carbon which was initially containing only one hydrogen atom. तो अब आप मुझे बताओ कि इसमें से which carbon was having lesser number of hydrogen atoms? Then it's obviously the second carbon was having lesser number of hydrogen atoms. And therefore, what you would say is that the first compound, 1-bromopropane, was a minor product, whereas the first compound, 1-bromopropane, was a minor product, and 2-bromopropane is a major product. नेगेटिव पार्ट विल गो टू दैट कार्बन एटम जिसके पास कम नंबर ऑफ हाइड्रोजन्स होंगे. This is a rule which is referred as Markovnikov rule. So this was about the hydrohalogenation of alkenes. In the next module, we'll learn about its mechanism, how exactly Markovnikov rules come into picture, and why do you say that a carbon containing more number of hydrogens and less number of hydrogen, for negative part should also always go to the carbon which contains less number of hydrogen. Okay, तो ये हम लोग next module में देखेंगे. For this module, it was only the pure addition of HBr. You will get two products. If it is an unsymmetrical alkene, अगर दो अलग अलग products मिलता है, definitely you need to determine who is major, who is minor. Major and minor would be decided upon a rule called as Markovnikov's rule. And the rule says that a negative part of the reagent goes to that carbon atom which contains less number of hydrogen atoms. So I hope this rule is pretty clear with you. In the next module, we'll meet again with the mechanism of the same rule. Till then, thank you students and happy learning.